You seem cooking.
I will.
It's time to start the forum for this Wednesday. All right, you guys, it's time to start. Okay, all right, let's try it again. Can you hear me okay? All right. Okay, so let's start the forum for this Wednesday, which is August 31st. I'll let the last couple people find their seats. So we are lucky to have Jeff Colton and Brianna Below. Yeah, I tried to make it harder than it is. They have already driven down from Grand Junction, and they are from the National Weather Service, and they've got a really, really good presentation. I'm going to give you a short bio on both of them, but before I do a bio on them, let me introduce myself. I am Phoebe Benziger, and I'm one of the four that's in charge of the forum, along with Kathy Hebers, Barbara Bynum, and Judy Ann Files. And we do this every Wednesday. It's open to anybody, so bring your friends. We start at 8, and we will promise to have you out of here by 9 o'clock. So if you have any questions, if you're not on our mailing list, see one of us after this. And we've also got some cards up here that you can take and scan in. And I think, yeah, like I said, bring your friends. Tell your friends about it, because you always leave informed. You will leave knowing something you did not know when you came in here. So, driving down, I said, is Jeff Colton and Brianna Below. A little bit about Jeff. He was born in Denver, Colorado, but raised as a military family, so he had a lot of moving around. Although he does call Denver, or he did call Denver home. I think he called Junction. I mean, he's been there a long time.
Junction longer.
Yeah, so born in Denver, raised military family, moved around, finally settled back in Denver, and he got his degree in meteorology from Montrose State University. He has a wife, 2 grown daughters, 2 step-granddaughters, and lots of grand dogs, which is more than Norman. Yeah, Norman. He has been employed by the National Weather Service for 30 years, 24 of them in Grand Junction. And as I told you last week, that's one of 3 stations in the state of Colorado. Is that correct, Jeff? He is known as an incidental meteorologist. So you're about to already learn something, so once you learn, don't get up and walk out because you'll want to hear more. Meaning he actually travels to where weather incidents are happening. So he's on call 24/7, 360 days, 65 days a year, 64/5, whatever year it is. This year he's only been called out once, but normally he gets called out 4 times. I'm not going to tell you what an incident might be defined as, but I'm sure that he will. So a little bio on Brianna. She's originally from upstate New York, but has lived in Grand Junction for 2.5 years. She studied at SUNY Oswego, am I pronouncing that? SUNY Oswego in Oswego, New York, for a bachelor's degree in meteorology, and then Plymouth State University in Plymouth, New Hampshire, for her master's degree in the same field, graduating in 2020. Always interested in weather and coming from a family with a strong emphasis on public service, she set her sights on the Weather Service from a young age, finally applying and getting the job at the Grand Junction office in early 2020. That was a fun year, wasn't it? Yeah. Yeah, there you go. In her time off, Brianna loves to hang out with her cat Della. She works on various knit and crochet projects, and she hikes. She's a bit of a national park geek and hopes to visit all of them one day. So, without taking up any more of their time, again, as always, if you're new, if this is your first time, I know you'll have questions. Try to remember what they are. You can ask them at the end. I will bring you the microphone. So, questions at the end. He will give us time for that. So I introduce Jeff and Brianna, and we'll start with Jeff.
All right, thanks, Phoebe. Again, my name's Jeff, and Brianna is my COVID kid. That's how I define all of the new hires that came in during COVID. So, not a fun time to come into the Weather Service because they were working in an office with one other forecaster trying to learn a job that normally we would have 5 or 6 people training them. So she's spinning up, we're getting her out there. We're gonna keep pushing along. But I've been on the west slope a long time, almost as long as she's been alive. So I know some of you are a little bit older than me. I'm just guessing. So real quick, the National Weather Service, there we go. I have to hear myself now. We have 122 forecast offices nationwide. Grand Junction, sitting right here, is one of those 122 offices. We cover 52,000 square miles of area. That's our forecast area of responsibility. One of the largest in the lower 48. Obviously, the Alaska offices are going to be much bigger with that. We cover eastern Utah and all of western Colorado west of the Continental Divide. So we're forecasting for 14,000 foot mountain peaks, and we're forecasting for valley floors down southeast Utah with the slot canyons and the low valleys down there. So life in the National Weather Service, what do? We are a 24/7 operation, so we're working day and night. There's always at least 2 people in our office, so the lights are always on. Except that one time I caught him sleeping on a midnight shift. It's not true. But we do a lot of forecasting, a lot of outreach activities such as the forum. We'd like to go out and work with the schools. We do a lot of weather observing, partner support, and research. Research is one of those things that, you go to school, you go through all that training, you don't really want to do research anymore, but you kind of have to keep doing it. You got to keep pushing on and learning about the science, and that's how we move on. And this one was a rare ice storm in the Colorado Rockies that we did. That occurred in Grand Junction. We had a lot of vehicles sliding off the road. We actually had ice falling on the west slope, which had never occurred from the people I spoke with for at least 100 years that we hadn't seen that. So we went ahead and did that science study on that. We launch weather balloons twice a day. There's 91 other stations across the U.S. that are launching those. Remote support, that incident meteorologist, that's one of the things I do. There's 88 of us in the nation that are trained to do this. We get deployed around the country, and I also been to Australia for 6 weeks for an assignment down there to help them with their wildfire season. So I get dispatched to wildfires typically, but I've also done flooding events. Larimer County Boulder floods a few years ago in 2013. Yeah, I believe that was 13. I was sent out there, and that was very different because I'm always dealing with wildfires, and now I'm dealing with flooding, so it's a little bit different there. But we've also done tornado cleanups, oil spills, and everything else like that. So what goes into a forecast? A lot of numbers, a lot of numerics. We call it numerical weather prediction, observations, and local experience. So one of the things that you guys need to remember for the test after this is this equation, the quasi-geostrophic geopotential tendency equation. But this is the things we learn in college. We go through all this, and we're like, what do we do? And the computers are doing all this for us now. But we still have to learn the basics and to have a better understanding of that weather. We are getting better and better in our short-term forecasts. Ingesting observations are put into these equations. So every time we're taking a surface observation of temperature, wind speed, barometric pressure, we've used that in these equations to help the computers determine storm patterns and prediction of those storms. And then data is interpolated by supercomputers. And those supercomputers are all out in Washington, D.C. They talk about teraflops and peptaflops. I don't know, doppelplops. There's all kinds of plops and flops. And these computers are getting faster and faster, and it's a race between the Europeans and the Americans on who can have the fastest supercomputers, and we're still trailing in that endeavor. So Europe still has its beat. But we do 2 types of forecasting: long-range forecasting and short-range forecasting. Long range is those models run about 4 times, and that's when you're going to hear the GFS model or the global forecast system or the European model. You'll hear that on the news sometimes. They'll say the European model's doing this and showing this, and they talk, especially when the hurricane season's spinning up, you'll hear a lot more of that. But just basically know that the American model and European model, and they both have their strengths and they both have their weaknesses. Forecasters we're trained to learn what those strengths and weaknesses are, and that's how it helps us improve our forecast for our area. The short-range forecasts, these are higher resolution. They run We have models that are running every 30 minutes now. We have hundreds of computer models that run. We're ingesting tons of data all the time. North American model is the NAM. There's a high resolution rapid refresh model that they're running on an hourly basis, so we get forecast how the thunderstorms are going to track. So not only do we have radar, but we have models that predict where those storms are going to go now. And they're getting pretty good, pretty darn good. It's kind of scary. So when we collect all this data, the supercomputer runs. We have 4 main levels that we look at here on the west slope. We look at the upper levels of the atmosphere. This is up at what we call 250 millibars, or where the planes like to fly. This is the jet stream level. So these bright colors are where the winds are the strongest in the upper levels of the atmosphere. This little dip here is what's known as a trough of low pressure. And then this is a ridge of high pressure on the East Coast. So we have flights like this. So if you're flying out to the East Coast on this day, you catch this jet stream and you'll be there a little bit faster. But the planes coming back to the west, they want to try to avoid these headwinds, so they might fly at a different flight level and try to get underneath those stronger winds or divert around those. Because those will suck the aviation fuel. This is a second level we look at. This is the 500 millibars, or about 18 to 19,000 feet above the ground. This is where most of our weather comes from for the western slope. And all these little yellows and reds are areas of atmospheric motion. It means the air is moving up or down depending on where it's at. And this circulation, this is a high pressure ridge. This is what we like to see during the monsoon season. We saw this a lot this year with this high pressure down here, and it helps draw moisture up around this ridge, and we get those rains and thunderstorms moving up from the southwest. Best position is a little bit to the east of that, but yes, you can see how that's working. Someone's at my door. Did you guys hear that? I forgot to turn off my ringer, so don't be scared if freeze miser comes on. So this is the next level down. We're kind of working our way down in the atmosphere. This is a 700 millibar chart. This is right about mountaintop level, roughly. We kind of look at it this way. Can anyone guess why this is white?
It's over 9,000 feet.
Yeah, so those
I used
are...
to live in Steamboat, I know about that.
There you go, yeah, so this is below the ground level, so these mountains are above this level that we're looking at. But this is kind of our surface map on the west slope. If we were to be out in the plains, we would use what they call 850 millibars, but out here, this is kind of what at least us older forecasters use this. I don't know what those guys do, those younger ones, but this is what we kind of consider the surface. And then there is a surface chart that's done. This one's the west. We lose a lot of the resolution as far as fronts and stuff. They get kind of lost in the mountains, but once you get out of the plains, you can see there's a cold front down here, there's low pressure here. All this green is rainfall, and the blues are ice and snow. Well, the reds are the ice, and then the blues are the snow. This isn't today, just want to make sure you guys know. I do have a really dry sense of humor, so might explain my forecast sometimes too. But observations. So we do weather balloon launches. This is now the science officer in Cheyenne, Wyoming. He was a bum when he was with us, but now he's grown up and moved on. This is what they call an automated surface observation system, or ASOS. These are located out at the runways. There's one here in Montrose. We service these from our office. We have electronics technicians that come out and will service these for you. We have, like I said, the weather balloon surface observations. We take sea ice observations, sea surface temperatures. There's buoys out there throughout the ocean that we're collecting data from. In the land and soil type and cover, satellite will determine that. We can look at how much moisture is in the soil from satellite, and we have sensors that are actually embedded into the ground. And then we have ground observations, radar, and satellite, and I'll go through those real quick. So the upper air data, again, this graph gathering a vertical profile of the atmosphere, so we're collecting temperature, relative humidity, wind speed, wind direction, and pressure. We launch that twice a day out of Grand Junction. We would love for you to watch us launch one if you're ever up there in Grand Junction at 5 a.m.
That's part of
or 4 a.m. It's gonna switch to 4 AM, with the time change,
Are we
so,
still doing the time change?
yeah,
I thought we got rid of it.
not yet. It's coming, supposedly. But yeah, the balloon launches are very exciting. There is a launch in the afternoon, 5 PM. That one's a little safer to come to. It doesn't scare us as much when someone shows up. So yeah, these balloons will travel up to about 100,000 feet into the atmosphere. We launch them twice a day across the world. It's not just the US. And 12Z or 0Z, this is Zulu time, but 4 AM or 5 AM depending on the time of year. And then this is a picture of our satellites. This is our newest satellite, GOES 16. Actually, GOES 18 is up there now. Because GOES 17 was the GOES West and that failed. So GOES 18 was launched and that one's spinning up. But this was our old satellite. It was all black and white. You turn on the news and you see color satellite, and there was nothing more frustrating for a weather forecaster, the National Weather Service, that we didn't have color satellite. It was maddening. It was crazy. I'm like, they have it on TV. Why don't we have it? So then GOES 16 came out, and now we have color satellite in our offices, and it's the most awesome thing in the world. And this thing can take a picture every 30 seconds, and we will get updates. It's faster than our radar. So it is really spectacular what they're doing with this, and it's a game changer because we can now see things like, anyone have a guess what this is? It's a forest fire, yeah. So we were picking that up. Sometimes we can see heat signatures on the ground, and we call the dispatch offices and say we're seeing a heat signature, so we know the fire's there before they go. That's how fast we can see these things now. But this is a particular fire that took off southwest of Meeker. We're watching that on set. Then we have thunderstorms down here and other things going on. So radars, there's a nation, 160 sites across the nation with radars. Ours is up on the Grand Mesa. I don't know if anyone's ever seen it, but it's a tan tennis ball up there. Paul Bunyan used to tee off up there, and 160 sites, like I said. We are the second highest radar in North America. That's cool, especially in Colorado, being Rocky Mountain High and all that. But the bad thing is we're overshooting a lot of our valleys. So this radar beam's going out. We can't see down into the valleys. We're starting at 10,000 feet and going up. So it's cool that it's high, but we can't put it down low, and I'll show you why. Because then we get into what we call beam blockage, and you see this wedge here. This is our radar up top. This is, Gunnison really hates this because they get blocked. We don't see a lot of activity down by Gunnison because the terrain blocks it. But we have different scanning techniques, and we can actually lift that radar beam up a little bit and see through this, but it is a detriment to that area. One of the things, this is the radar. This is a wildfire down in New Mexico I was on, and this is the radar out of Albuquerque. I was able to pick up the smoke plume on radar, so that's another advantage to that. No, that's not what you want. It sounds like some kind of jungle stuff.
Kookaburra. Let's try that.
I love this one. It was awesome. So yeah, this smoke plume, you can see how the smoke's dissipating, and we can see the winds, and we can do this with thunderstorms too as well. We can interrogate those thunderstorms and look at it in 3 dimensions. So our office is located right at the tower at the Grand Junction Airport. Localized experience is a huge factor in weather forecasting, because the longer you live in a place, the more tuned in you get to that area. But the really important thing is when a new forecaster gets there, it takes them probably a year to spin up. They need to go through every single season before they actually start to recognize weather patterns out here. And even then, they're only going to recognize it for Grand Junction. It takes them another 2 or 3 years to start recognizing, oh, this is what happens in Montrose in this pattern, this is what happens in Gunnison. It took me 3 years to figure out Steamboat Springs, and I'm still trying to figure out Durango. That place is crazy down there. Depending on the wind flow and the direction and the time of year. January, it used to be, all we saw was snow. When I was a kid growing up in Denver, once it started snowing, it didn't stop snowing until spring. It was always snow. But now we get rain in January, and it's frustrating, but we're seeing warmer systems coming on shore. How many have heard of the Pineapple Express? Yeah, well, it's now the atmospheric river. That's the new term for it. It's the politically correct term is atmospheric river. But they're warmer, and they're coming in and they're keeping those temperatures right around freezing. So we're seeing more rain than snow in a lot of areas. Not too long ago, we had 5 feet of snow in Crested Butte. It was in an atmospheric river. But in Aspen, on the other side of the mountain, because they were getting some downsloping winds, was rain. So they weren't happy with us. Crested Butte was loving us. So those are things that, as a forecaster, getting that local experience is really, really important. So some of our challenges, I'm almost done too. Mountain meteorology, obviously the complex terrain, the microclimates, the lack of observations, snow levels, which I just brought up there. Challenge number 2 are burn scars. Rock and avalanche slides are the remnants of them, because this creates areas where we can see debris flows, portions of burn and slide respond differently, storm motion intensity. All these mountains out here just really disrupt our weather patterns and throw us fits. And then fire weather is probably our biggest challenge on the west slope, because we do see a lot of fires, especially over the last 20 years. When I moved to Grand Junction, I didn't really know what fire weather was because I came from Texas. I was in Amarillo for a while. I was dealing with tornadoes out there, so I moved out here. I was like, what's this fire weather stuff? And I quickly learned what fire weather was. And when you're dealing with complex terrain, you're dealing with humans. About, I want to say 60 to 70% of all the fires in Colorado are started by humans. That means only 30 to 40% are being caused by lightning. But how many have heard of the red flag warning? All of you? If you haven't, you've been living in a closet. So we have red flag warnings. We issue a lot of them, and they have gotten more frequent. I know I've talked with Scott here about these. We're looking into that, but that's one of those things we'll be dealing with until we start to see better moisture moving back into the region. So I want to talk really quick before I shift over to Brianna about weather and climate. And one way to describe weather and climate is like walking your dog. Or if you have a toddler that you're trying to take on a walk. A dog's gonna go randomly walking around all over the place. That's your weather, that's your day-to-day conditions. This dog is randomly moving around, and that's gonna, I don't know. A well-trained dog's gonna walk a straight path, I know that, but I don't have well-trained dogs. I have a Chihuahua, and he barks. That's what he does. But climate is the average of all those wide range of days, so we try to smooth it out. So he's walking a path, he's trying to stay straight, but the dog is going to be your day-to-day weather, so he's moving around quite a bit. So climate's describing weather, what weather is like over a long period of time. It's the seasons. Try to tie the 30 years of data, but we're starting to look at 15-year blocks, and then there's 100-year blocks that we can look at as well. One thing what we've noticed here on the west slope, we've taken a look at a lot of the observation sites that are long-term observation sites. These places have been in place for 50 to 100 years or longer. And one thing, especially up by Steamboat Springs, we noticed in Crested Butte, high temperatures really aren't changing a lot. It's the low temperatures. We're seeing the low temperatures at night are warmer by 2 degrees in a lot of areas. So that's where you're seeing, at least in western Colorado, we're seeing the little nudge in temperatures, but it's mostly at the low temperature side. So it does help our growing season until you get that spring freeze that wipes everything out. So I'm going to pass the baton over to Brianna, and then I'll be back for half an hour here.
All right. Hi, everybody. I'm Brianna, by the way. So we'll look a little bit at precipitation formation, just because precipitation is kind of an important thing out there when we do get it. So there's 3 main ingredients that you need to actually get precipitation, to get storms or rain showers or whatever. You need moisture. This can come from the Pacific Ocean, which is including the Gulf of California. That's typically where our monsoonal moisture will come from. You can also get some from the Gulf of Mexico. You also need instability, so this is just basically the atmosphere is unstable, it allows air to rise. You need rising motion to get these sort of things. So warmer near the surface with colder air loft, and you also want an increase in low-level moisture at the surface, or a decrease in that moisture up higher. And then you need lift. We've got lots of sources for lift out here. We've got mountains. But you can also get lift from fronts or outflow boundaries. So thermal or convective lift, basically you heat up the top of the mountain and the air wants to rise to go up there, and in that it forms a cloud as it rises. So you get strong heating of the air near the ground, which produces these thermal updrafts. If you've ever watched like birds like vultures or crows or whatever just circling around, they're riding those thermal updrafts. And it's a convective current, and these happen for the most part in the summer. They can happen all year as long as you've got enough heating. And this occurs during the day up in the mountain ridges, as that thermally driven heat kind of drives these winds on opposing slopes to rise up together. And then we've got orographic lift, which is in a way kind of similar, but basically you have winds coming up over the top of a mountain. So the ascent, it's actually forced by the air moving over the mountain itself. You don't have those winds kind of converging at the top. If the air that's forced over the mountains is sufficiently moist, you get precipitation. This happens a lot, like in the Pacific Northwest. That's why it's so rainy in like Seattle. You get that orographic lift where you get moist air coming off the ocean, hits the mountains, you get precipitation. And you get what's known as a precipitation shadow on the lee slope. So basically, all of the rain happens here. And then as the air moves downslope on the backside, it dries out, it warms, and you get nothing. So out on the front reach, you get what's known as Chinook winds, which is just a specific form of these downsloping winds. And you also see an increase in relative humidity over the mountains. And then there's also upslope winds, which are winds that develop over the slope of the mountain due to heating from the sun specifically. So whatever side gets the most sunshine at that particular time of the year will be the one that has these upslope winds develop. And this typically occurs during the afternoon. You'll actually notice when the wind switch to upslope here, you'll actually notice that wind change between like 1 and 3 in the afternoon. And then correspondingly, there's downslope winds, which typically happen at night. And these are winds that develop over the slope of the mountains as they cool after sunset. So that cooler air up here, it's denser, it wants to move down. So these are more common during the night. I don't know how many of you are up at 4 or 5 in the morning, but you can also notice this wind shift as well. We noticed it at the office because that's about the same time we launched the weather balloons. As far as atmospheric stability and fog formation, a lot of what we get out here is it's known as inversions. So basically the temperature increases with height. So you have a cool temperature at the valley floor, but it's increasing up to a certain height above. Out here, a lot of times you'll see that at ridgetop level. That's where your maximum temperature will be. And so it traps smoke, fog, pollutants in the valleys, and you get these fog and low stratus layers, and it just kind of gets murky. This happens a lot in the winter. It's colder in the valleys, it's warmer in the mountains. It doesn't seem like it would make sense, but again, the cold air, it's denser, it wants to sink down into those valleys. So moving on a little bit, we'll talk about types of hazardous weather. So the ones that we'll talk about here is flash flooding, winter weather, fire weather, severe thunderstorms, tornadoes, and hurricanes. So we'll talk about the ones that affect us the most first, and then the ones that affect us the least last. But we do actually get some effect from all of these things out here on the western slope. And these are just some examples of things that we've seen out here over the years. So looking at flash flooding, so the technical definition is a rapid or extreme flow of high water into what is normally dry, or a rapid rise above flood level in a stream or creek. We often see this with extreme rainfall in thunderstorms. We can have this occur with one cell that's producing a lot of rain and moving very slowly, or we can see this with multiple storms moving over the same area in what's known as training. They move like a train on a track, they just go over the same area. And our area is actually really prone to this kind of flooding because we have very rocky, mountainous terrain. We don't necessarily have a lot of soil to absorb that moisture, so it all just kind of runs off. As far as winter weather, as we all know, especially up in the mountains, winter storms can bring feet of snow. We can see sleet, sometimes even freezing rain, as Jeff mentioned earlier, with that really rare ice storm event. The mountains in Colorado get some of the largest snowstorms in the country. As far as dangers, the weight of the snow can collapse roofs, knock down trees, knock down power lines. You may end up with homes or farms isolated for days, and unprotected livestock can be lost. You can have heavy snow that leads to avalanches, and we'll talk a little bit about avalanches coming up. And it can make really difficult to dangerous travel conditions. That's one of the biggest impacts that we notice at the office, is that it makes traveling really hard. We have what's known as snow squalls. We've been seeing these a lot more in recent years. So these are intense, short-lived bursts of heavy snowfall. You often see a very dramatic reduction in visibility. It doesn't last for super long. These happen on the order of maybe 30 minutes to an hour. But they're often accompanied by gusty winds, and these typically occur during daylight hours and may also cause flash freezing on roads. These are really, really, really dangerous to travelers. They're similar to blizzard conditions, but they're more localized and shorter in duration. But you may still see a significant accumulation of snow. There have been snow squalls where we've seen 2 or 3 inches over an hour. And these can cause chain reaction accidents. Ice jams, we don't see them as much here in Montrose, but you can see them in other places like Gunnison, where a river or a stream gets blocked by chunks of ice. Ice jam floods are less predictable and potentially more destructive than just open water flooding, which would happen when you get a lot of precipitation. So these are dangerous because they occur unexpectedly. They're typically not thought about, especially in the wintertime. These cold temperatures in the water can cause hypothermia. We've been seeing these down in Gunnison, and we've also seen them quite a bit on the Roaring Fork. Avalanches, a large amount of snow that moves quickly down a slope. It can bury or sweep anything away that's in its path: trees, rocks, boulders, cars, houses, whatever. And these are most likely to occur after a heavy snowstorm. So these are just some images from various avalanches we've seen over the years as well. This one in Durango, and these one over Red Mountain Pass in 2019, which I wasn't here yet, but I remember seeing on the news about all the avalanches that you guys had out here. Fire weather, as Jeff mentioned, this is what keeps us busy during the dry seasons. Wildfires are unplanned and unwanted. They are pretty dangerous to people, especially if you're outdoor recreating. They can be caused by lightning, or more likely humans, whether it's carelessness, whether it's arson, whether it's just an accidental thing with like a dragging chain on a car. Fire weather is one of our most impactful weather phenomena. I'm sure a lot of you remember how bad 2020 was as a fire season. I want to talk about trial by fire. That was my first year here. Critical fire weather conditions. So these are our definitions that we use to define critical fire weather. So you need to have dry fuels. We get that from a lot of our partners who look at these fuels. So that's your vegetation. You need low relative humidity, so we're looking at 15% or less. You need gusty winds of more than 25 miles per hour, and you need all of this to last for at least 3 hours. And these are just some fires that we've seen. This is Pine Gulch, which was just north of Grand Junction. And then the 416 fire, photo courtesy of Jeff. And Jeff told me this one. Wildfires are the gift that keeps on giving, because after the fire, you end up with post-fire landslides and debris flows. These are highly destructive. They occur in the years immediately following wildfire, so typically in that first 3 years. and they are triggered often by high-intensity rainfall events, and they're especially hazardous because they can occur with very, very little warning. So this is a post-416 fire debris flow, but I'm sure all of you have heard about the Glenwood Canyon debris flows that we had last year. Same thing. These are actually some of the photos from that now. Yeah. Moving on to severe thunderstorms. So again, official definition here. These are storms that are capable of producing hail that's an inch or larger. So that'll damage plants, roofs, vehicles. Or they can produce wind gusts over 58 miles per hour, which can break large branches, knock over, cause structural damage to trees, potentially cause power outages. One or the other of these criteria has to be met for a storm to be severe. But thunderstorms can also produce tornadoes, dangerous lightning, or heavy rain to cause flash flooding. Moving on to tornadoes. So violently rotating column of air extending from the base of a thunderstorm down to the ground can completely destroy well-made structures, uproot trees, hurl objects through the air. Since 2007, we have what's known as the Enhanced Fujita Scale, or the EF scale. If you've ever heard of the F scale, this is just a update of that. And the categories are over here. Typically on the west slope, we see EF0s, maybe EF1s, although I do think we've seen EF2s. I don't know about EF3s, I haven't been here long. So tornado myth busting, we'll go through this pretty quick, but all of these statements are totally false. Tornadoes can't hit big cities. They absolutely hit big cities. They had a tornado in Salt Lake City. Tornadoes can hit big cities. Tornadoes are attracted to mobile homes. That's not true. It's just that a lot of these kinds of structures are more susceptible to that type of damage. Tornadoes can't cross water. They can absolutely cross water. They can occur exclusively on water. If you've ever seen land spouts, like off of the coast of Florida, or water spouts. Tornadoes can't travel up and down hillsides or mountains. Again, this can absolutely happen. We've had tornadoes out here that have done this. And then I'm protected by tornadoes from whatever reason. You've got a magic dome around your city that causes the storms to split, whatever your reason is. No, they can happen to anyone, anywhere. Hurricanes. We don't see hurricanes in the full sense out here in western Colorado, but we do still see impacts from them. So there are among nature's most powerful and destructive phenomena. You can have winds exceeding 157 miles an hour. Over a typical 2-year period, the U.S. will be struck by an average of 3 hurricanes, one of which will be classified as a major hurricane, which is a Category 3 or higher. And what we see here in western Colorado is typically the remnants of a tropical system, so you get some of the wind, a lot of the rain, and that can go back to the flash flooding that we discussed, which can cause a lot of problems. And here are just some impacts that we've seen from hurricanes in southwest Colorado. So in 1911, they actually had the remnants of a tropical system, which brought devastating rain to southwest Colorado. It destroyed more than 100 bridges, caused several deaths, destroyed more than 300 miles of railroad tracks, completely cut off the area as far as communication. The majority of crops in the Animas Valley were destroyed, and in today's money, over $40 million worth of damage. And I will pass it back on to Jeff.
I saw a typo on that last slide. Dang it. We've been using this for like 2 years now. It was a double dub. I don't know if anyone saw it, but it was a double dub. Kind of ruined my day right there. Situational awareness. Are you aware? Do you know what's going on? This is very important. I believe when you're planning your week, your days, just to take a quick look at the weather forecast, plan your action. How do you get your weather forecast? Do you listen to the radio? Do you have a normal weather radio? Are you getting it off Facebook? If you're getting off Facebook, beware, because sometimes those posts could be a week old, and you're not paying attention, you don't see that. If you're on Twitter, our office is pretty good at posting things on Twitter, at least 2 or 3 times a day, maybe more. If we have weather going on, it's much more frequent. But that's kind of the outlook, kind of get a feel for what's going on. And as you get closer, we issue things that are called watches. So like a winter storm watch, or a severe thunderstorm watch, or a tornado watch, flash flood watch. All of that gets issued if the atmospheric conditions are right for that type of hazardous weather to occur. So you want to be closely monitoring things and be prepared for it, but doesn't mean it is occurring. So a watch is, let's get ready, something might happen. So a warning means that we are anticipating it to occur, it's imminent, it is occurring, or will occur very shortly. So that can, you need to take steps to protect yourself at that point. So if you hear a flash flood warning, don't question it, just take action, because sometimes it might not be there yet, but chances are it's coming. Ask the folks in Moab just last week. I went down there, we had the flash flood warning out, they had about 2 hours of notice before it actually hit. So those are things to be aware of, that we're seeing things on radar. If it doesn't happen, great. I mean, there's a lot of folks in Moab that are a little upset because their landscaping's been totally destroyed. It's gone under a foot of mud. So these are the different types of mechanisms you can get our forecasts from. Like I said, weather radar. I'm not going to tell you where to get your weather radar. We do not actually have an app for your phones. If you see a National Weather Service app in the App Store, it's not ours. We don't actually have one. We don't compete with the private sector. We allow them to develop the apps for weather safety. So, but there are, you'll find that there's several apps out there that will show you weather radar. You can pull it up on our website as well. It's not the best radar page, but it does work. Mobile forecasts. You can get those, find your favorite weather app, and then social media as well, we're on there. And then your cell phones. If we send out a flash flood warning we have different tags, and they will trigger the wireless emergency alert system, and that will trigger your phone. So it's geocoded based on where you're at. So if you're driving along the road in Kansas and your phone goes off, that means there's something going on in that area, so you need to pay attention to that. So there's been advances in the science, and we're using what we call polygon warnings, so we're not drawing these big boxes anymore. It's a little more specific and trying to tie it into that area, and that way your phone's not going off at all times of the day and night. Quickly on flood safety, like I said, check the forecast, but if a flash flood is occurring, you want to move to higher ground. You want to avoid low spots in the canyons. Just kind of stay out of the way and evacuate if you're told to do so. Follow the local emergency management and the sheriff's departments and listen to what they're saying. Winter weather, best thing to do, stay home if you can. If you are out traveling, make sure you have a survival kit for your vehicle. A lot of us kind of ignore this in the West because our, CDOT does a great job keeping our highways open. We don't ever think about that. But if you're out in the back country, hunting, camping, fishing, hiking, or doing whatever, you could get yourself trapped back there. And that's one of the big things we see is with hunters, especially in October, they get caught, they're out of state, they don't understand that we could go from 70 degrees to a foot of snow in 24 hours. So that's when this becomes very critical. Dressing in layers, obviously. For fire weather, prepare and have a disaster plan. Have a go kit, especially if you live in a fire-prone area. So have your important papers and documents loaded up, ready to go in case there is a wildfire. You know the seasons, you know the time of year. Most likely it's going to be March, April, May, June. That's our driest, we're moving into the dry time of the year. Then I'm not going to tell you the bad news that's coming up. It's coming up. Besides. Severe thunderstorms, again, we don't see a lot of these out here, but we do see them. Mostly when we see a severe thunderstorm, it's going to be wind. That'll be wind gusts of 58 miles an hour or greater. Sometimes we might see a 1-inch hailstone, but it's pretty rare on the west slope. But you're just going to want to go inside into a sturdy building, get away from trees. Why would you want to get away from trees? Lightning. Lightning's going to strike the highest object, and a lot of people get electrocuted from the lightning passing to the tree roots, and they don't anticipate that. So we see that Lightning's one of the biggest killers in the US. If you can't get to a shelter, you can crouch down in an open area and cover your ears. Tornado safety, I don't go through this a whole lot because it's such a rare event on the west slope, but if one were to occur, you want to go into an interior building or interior room of the building or into a designated tornado shelter, which there aren't a whole lot in our buildings out here in the west, but a lot of schools you'll go in the hallway and get down in the crouch position. When I lived in Texas, this is a really big deal, but out here, most of our tornadoes are real small. I did get a documented tornado on Purple Mountain, which is between here and Crested Butte, about 12,000 feet in elevation, which would make it the highest documented tornado in the U.S. We're still waiting on confirmation on that. I got video, so I wouldn't have believed it if I didn't get the video. So.
When was that?
Year and a half ago, too. It was a COVID tornado.
Early 2021, I think.
Yeah, I couldn't believe it. Somebody's out there and they had their cell phone camera and they got it. It's just crazy. You don't know where. So here's the good news. Our drought that we've been suffering in has improved greatly across the west slope. There's a new one coming out today, I believe. It didn't even show more improvement. But this was last year at this time, and this is now. So we moved from extreme to exceptional drought into moderate to severe drought. So improvement, it's better. It's been raining, but we're still in drought conditions. Unfortunately, looks like we might be going the other direction here shortly. This is a fire outlet, significant fire potential for the rest of September. A little bit in northeast Colorado, but pretty much average for this time of year. This is the seasonal outlook for September, October, and November. This is from the Climate Prediction Center, and it showed a big bullseye of above normal temperatures and below normal precipitation. But take that with a grain of salt, because these are just probabilities of exceedance. So this below normal probability that we're showing here is about 40 to 50% chance. So if you took a dartboard and you stuck it up there, the wedge for the below would be a little bit bigger, and the wedge for the normal would be smaller, and above normal. And if you're like me and you're throwing darts, you're pretty bad. So you have a good chance of hitting above normal too. So, but if you're really good, then you're going to hit that below. It does look like it'll be warmer. Tell me if you haven't heard that one before. So, there's December, January, February, your winter outlook. For those that follow the Farmer's Almanac, I've not read it yet, so if you have any intel, let me know. But this is what we call a La Nina pattern. It would be the third consecutive La Nina that we've seen on the west slope. It tends to favor the northern mountains, with the southwest part of the state drier conditions typically in this pattern. So that's where winter is headed. It's looking like pretty much normal winter for our neck of the woods, and then maybe above normal up towards Steamboat. That's the good news. San Juan's not so good. And I believe that's the last slide. So we do have 12 minutes for questions.
Yes, we do have time for questions. Let's give them a round of applause for speaking.
You mentioned the Farmer's Almanac just now. Who's responsible for that, and how does that tie in with your weather, which is so complex? How's the Farmer's Almanac in terms of accuracy?
That is a wonderful question, and I assume it's a farmer putting that together. I honestly don't know who put it together. I read that Farmer's Almanac like the Bible when I was a kid, and I was amazed at how accurate they are. Kind of scary, but I honestly can't say. Do you know? But I don't know who's putting it together. But as far as tying in with what we're seeing, I think there's a bigger effort of making sure their forecasts are kind of aligning with the long range from the Climate Prediction Center, so there's less confusion, because sometimes they come out and it's vastly different what we're seeing. So there is a little bit of effort there. I know that didn't really help, but
So when we see a lot of these major weather events, a lot of them are labeled, this is a 1,000-year event, which leads me to say, well, don't worry about it, it's not going to happen for another 1,000 years, except that it happened 2 years before and 4 years before that. Do you use a 1,000-year event? You know, and then if you do, how did you know what it was like 1,000 years ago?
I personally didn't, know, but I'm gonna pass this to, she's actually our climate person.
So those definitions, the 1 in 100 year, 1 in 500 year, 1 in 1,000, it actually, it's more of a probability. So a 1 in 100 year event means that there is 1/100th of a chance each year that it could happen. It's unlikely, but it's not impossible. So the same thing with the 1,000 year. It's based on the climatic record that we have, both what we have from records back to the 1880s or whatever, and also we have people who do like paleoclimate modeling, so they can look at what the climate was thousands of years ago based on things like tree rings and ice cores and stuff like that. But yeah, those definitions basically are just saying that there's a small chance that can happen in any given year. And I know what you mean, because where I'm from in upstate New York, we had 2 1 in 500 year floods 5 years apart. So like it happens, and it's getting more common now that you see these really rare events happening more often than you think that they should. But yeah, those definitions have more to do with just a breakdown of how likely is any event to occur in any one year. I hope that helps.
So I have a question. So weather it's cool. We all like to know the weather. It's fascinating science. But I'm wondering if the organization has a mission in terms of why it matters. Are you trying to protect life? Are you trying to protect property? Like, why are we concerned about the weather? What's the ultimate goal?
Well, the mission of the National Weather Service is the protection of life and property. So that's our #1 mission out there. We also are wrapping climate into that now. We're bringing climate. We want to make the nation a climate-ready nation and a weather-ready nation, both. So protecting ourselves for the now and the future.
Life and property.
Yep.
Do you generate forecasts for general aviation, or is that another department?
Nope, we do that. We forecast 11 airports on West Slope, I believe.
Yes.
So we provide specific forecasts for those airports, and we do that 4 times a day. And it's a workload. She's passing the microphone.
I would like to know everything about the weather balloons. How are they made? What instruments are on them? What do they cost? What's their life expectancy? What happens to them when they're done?
We used to use helium, now we use hydrogen. The balloons are what we call 200 gram, 400? 600 gram. See, I use a 200 gram balloon with my fire weather kit. But they have a small instrument attached the size of a shoe, smaller than a shoe.
About the size of my phone.
Yeah, they're pretty small.
We used to have bigger ones, we just switched.
They are tracked until they pop. Then there's a parachute attached to them. They cost about $250 per launch was the last cost number I had. The balloon will float, or the parachute brings the instrument back down to the surface, and then if it's found, it can be returned and refurbished. I don't know about the new ones. The new ones are not, but the old ones, we actually had one returned to our office that had been sitting in a field by DeBeck or Parachute from 1986. Yeah, it had been sitting out there, and they found it, and it was still there. So it was a real big box. So they do sit out there. The new ones have more biodegradable material in them, so they can break down faster. But the old ones, they're out there. If you're out hiking, you might find one.
So they're trash either on the land or the ocean.
Correct. Yeah, no good news there. Sorry.
What is fun is you can track them after the balloon is popped. We stop tracking them, but they don't stop sending a signal. So you can track them and you can go find them.
And we do have groups of people that actually do that. They go find those balloons, and they take them off the landscape.
Okay, one question about cloud seeding, you didn't mention anything about that, but that used to be pretty prevalent on the western slope. Does that work? Is it still being done?
Yes, it is still being done. Many cloud seeding programs are still being sponsored by the state of Colorado. And they coordinate their seeding efforts with us. As far as it working, no one's ever told me if it works, and I don't follow that. And the only way they would know that is to do those samples to see if those silver iodide showing up in those snow crystals to determine that. It must be working somewhat because they keep doing it. But there's one up on the Grand Mesa, and there's some up by Crested View too that I know that they're seeking. So.
Okay, so we have time for one more question, and then you'll be around and about if people have more questions afterwards, correct?
Yeah, and we can arm wrestle with the sheriff's department.
Can you explain the percent probability of thunder shower? Because I don't pay much attention until about 80%.
That's funny you bring that up, because when I was a kid in Denver, if they said 40%, I knew it was gonna rain that day. Because it always rained at 40%. When they said 80, it didn't rain. So it was really weird back then, but now when we say 80%, you can pretty much guarantee it's gonna rain. We're getting that good, but wow, this is a loaded gun because
It's hard for us even to wrap our heads around the definition.
yeah, because we forecast for zones. We have a big zone, so like Montrose is a zone, the Grand Mesa is a zone. When we say 40% chance, that means 40% chance, 40% of that zone may see rainfall. 60% of it won't. Are you in that 40%? We don't tell you that part. So,
Basically, if there is a percent, it's going to rain something. The higher the percentage, the more likely it'll rain where you are.
and yes, they still pay us, so
Okay, you guys, thank you, Jeff, thank you, Brandon. That was a great presentation.